Hi everyone! Our lesson for today is Lesson 1, Functions. But before anything else, let's review. First question. It is the set of first coordinates. Is it A, range, B, domain, or C, abscissa? The correct answer is B, domain. Second question. It is the set of second coordinates. Is it A, range, B, domain, or C, abscissa? The correct answer is A, range. So domain is the set of first coordinates, and range is the set of second coordinates. Now, let's find the domain and range of the given ordered pairs. So let's find out the domain and let's check what are the first coordinates. So we have -1, 0, 1, 2, 4. 1, 2, 0, -1, 4, -1, and 4. Second one is the range. Now let's check the second coordinates, which are -1, -3, 5, 3, -5, 5, and -4. So as you can see, the numbers here are already arranged in a number line. Now let's move on to our main topic, which is function. But let's first define a relation. So a relation, it is a set of ordered pairs. So there is no any condition. A relation is just a set of ordered pairs. And a function, it is a relation in which each element of the domain corresponds to exactly one element of the range. So take note of that. Anyway, later on we will have some examples for us to understand more about function. Functions can be represented in different ways. We have the first one, table of values. We have ordered pairs. We have graph and an equation. So we can determine if the relation is a function using these four different ways. So let's have the examples. Which of the following relations are functions? Let's have the ordered pairs. So we have set F, set G, set H. So which among these three relations are functions? This is or these are set F and set H. Why is these two are the correct answer? Now let's check their domain. If we have one element of domain that corresponds exactly one element of range. Okay, so we have here 1, 2, 3, and 4. And set H, we have 1, 2, 3, and N, and so on. How about G? Why G is not a function? It is because we have one here and we have another one here, but we don't have exactly one element of range that corresponds 1. Okay? So 1, 3, 1, 4. And we have another 2 here. So 2 has 2 element of range, which are 5 and 6. That's why set G is not a function. Now, next example. Determine whether the relationship given in the mapping diagram is a function. So the first circle here is the domain. Second circle is the set of second value or the range. So we have 10, 15, 20, 45, 30, 25, 40, 35. So do we have one element of domain that corresponds exactly one element of range? Yes or no? So the correct answer is yes. So this given relationship is a function. Next example. So take a look at this mapping diagram. Do we have one element of domain that corresponds exactly one element of range? So it is yes. So this given relationship is a function. Now, let's have the term vertical line test. So vertical line test, a graph represents a function if and only if each vertical line intersects the graph at most once. Okay, so it means that if we're going to put or draw vertical line here in this graph, we must have one point of intersection. So in the first graph, first example, here the blue line is the vertical line and the red line is the graph. And if we're going to draw a vertical line here, we can only have one point of intersection. So this graph is a function. How about the second one? We have circle here. And if we're going to draw a vertical line, if we're going to do a vertical line test, we have 2 points of intersection here. That makes this graph not a function. Let's have some examples using vertical line test. Okay, so we have this kind of graph. Is it a function or not function? So the first one is function. So vertical line here, one point of intersection. Second one, which is a circle. If we're going to draw a vertical line here, how many point of intersections? We have 2. So the second one is not a function. Next examples are this one and this. So vertical line test here or here, wherever you want. So how many point of intersections? So we will have 2 point of intersections here. So it means that this is not a function. How about here? The line is a straight line. So if I want to put a vertical line here or here or here, we can have one point of intersection only. So it means that this graph is a function. Next one. Okay. The first one is function. Second one, take a look at this graph. It is like a wave. And if I'm going to draw a vertical line here, how many points of intersection? It is more than once. Okay, we have 1, 2, 3, 4, 5, 6. Right? And if I want to draw a vertical line here, we will have 6 points of intersection. So it means that this graph is not a function. Now, let's use some equations. Which among these 6 equations is or are functions? So the functions here are the first one, third one, fourth, fifth, and sixth. So why is it that the second example is not a function? Let's explain why. So let's have the first one, which is y is equal to 2x plus 1. The reason behind why this equation is a function is, first, it is a linear equation. When we have a linear equation, which we have tackled in grade 8, we can have a straight line, right? And if we're going to draw a vertical line here, or if we're going to use vertical line test, we can have one point of intersection. So it means that the first equation is a function. How about the second one? In the first example, why is that this equation is a linear? Is it because the highest exponent here is 1? And the second one is a function y is equal to x squared minus 2x plus 2. And this is a quadratic equation because of the exponent 2 here. And the graph of a quadratic equation is like this. Not all quadratic equation has the graph of this one, okay? It such happens that the value of the first term here is positive. So the graph is like this. So if we're going to draw a vertical line test here, we can have one point of intersection. Third, okay, so actually, how did we come up with this kind of graph? It is because we set some values of x and then found some values of y, and then we graph the points. That's why we have these kinds of graph. Now, if we're going to put or draw for vertical line here, it is like this, okay? So it is a function. Second one, it is a rational equation. So some rational equations, the graph is like this, okay? Actually, the graph here is just tight, that's why it looks like this. But if we're going to draw a vertical line here, we can only have one point of intersection. And how about the last one? Y is x squared plus y squared is equal to 1 is not a function. So the graph of this is like this. It's a circle. So first, for us to determine the value of y, we must express y in terms of x. So we will have two values of y here, okay? So it means that it is not a function. Now, time to test yourself. Let's have some activity. Determine whether the following sets of the ordered pairs represent functions or not. First one, is it a function or not? Not a function. Second, function. Third, not a function because we have negative 13 here and another negative 13, and we have two elements of range. Number 4, it is a function. Now, next examples. How about this one? We have here 3 as the first coordinate and 4 numbers here, 4 different numbers for the second coordinates. So it is not a function because we have 4 elements of range. How about number 6? In number 6, we have x5, y5, u5, v5, L5. So in each domain, we have corresponding, we have one corresponding element of range. So it is a function. State whether each graph represents a function. So we're going to use vertical line test here. So number 7, is it a function or not function? Not function. Number 8, it is a function. Here, if we're going to draw vertical line here, we can have 2 points of intersection. But here, wherever you want to draw a vertical line, you can have only 1 point of intersection. That's why number 8 is a function. So, thanks for watching. See you in our next lesson. Bye!